All right, get ready to dive deep. Today, we're going to explore cutting-edge research in AI. Specifically, we're looking at large language models. The systems that can write poems, translate languages, even code. It's the kind of stuff that used to be pure science fiction, right?
Absolutely. And what's really fascinating about this specific research is that it tackles a pretty fundamental limitation of the LLMs that we have right now. They're really good at mimicking human language. I mean, they're amazing at it, but they don't actually understand language the way that we do.
That's exactly what I find so intriguing about this. They can create this text that sounds like a human wrote it, but do they really get the meaning behind it?
That's the million-dollar question. And a team at Meta, they think they might have found a way to bridge that gap. And they've got this revolutionary new approach called the Large Concept Model, or LCM.
Okay, so we're going to be dissecting excerpts from the paper Large Concept Models, Language Modeling in a Sentence Representation Space by Loic Burrell and his team of brilliant minds at Meta. And their big idea is that the key to AI understanding isn't just processing individual words, but thinking in concepts.
Precisely. Think of it this way. When you read a book, you're not just taking in a stream of words, right? You're building this mental model of the characters, the plot, the themes. You're thinking in those chunks of meaning, those whole ideas. And that's what the LCM is trying to do.
So instead of kind of getting bogged down in all those tiny little details of each individual word, the LCM tries to grasp whole sentences or ideas as single units.
Exactly. It's a much more hierarchical approach to language processing, much closer to how our brains naturally process language. And what's so cool about it is they actually define concepts as entire sentences in this study.
Wow. That's a pretty bold move. I'm guessing this shift to thinking in concepts leads to some pretty interesting results.
Oh, it definitely does. The researchers explored a bunch of different ways to build the LCM, and one of the things they found was that the most effective models utilized something called diffusion.
Diffusion models.
Yeah.
Now, I'm familiar with diffusion models when we're talking about image generation, but I'm curious how they apply to language.
Okay, so imagine you have a perfectly clear picture, and you start to slowly add noise to it little by little until it's completely obscured, right? A diffusion model learns to reverse that whole process. So it starts with just pure noise and then gradually refines it step by step until it reconstructs the original image.
Okay, I see. I'm starting to see the connection here. So they're applying that same concept of denoising to language, essentially.
Exactly. In the LCM, they start with this kind of random representation of a concept, and then they gradually refine it based on the context, all the sentences surrounding it. And it keeps going until it arrives at this accurate and meaningful representation.
So it's almost like the model's learning to see the signal through all the noise, just like in image generation.
Exactly. And what's remarkable is these diffusion-based LCMs, they were significantly better at predicting the next concept in a sequence than the more basic, simpler models. They really excelled at capturing those subtle nuances of meaning and the way that ideas flow together.
That's seriously impressive.
Yeah.
And so they're onto something really special with this diffusion approach. But I'm curious about the practical side of things. How do they actually train these models? Do they need some specific kind of data?
Well, they experimented with a bunch of different text corpora, just to see how the LCM would perform in different contexts. They used everything from short stories to news articles to even encyclopedia entries.
But they're basically throwing a wide range of textual experiences at it to see how well it adapts. I love that.
Yeah. And one of the challenges they ran into was figuring out how to accurately split the text into sentences, especially when you're dealing with a truly massive amount of data.
I bet that gets super tricky. A simple period doesn't always mean the sentence is actually over, especially with all the, abbreviations and different writing styles out there.
Exactly. So they had to come up with these pretty sophisticated techniques to make sure that the sentence segmentation was actually accurate. They found that this one method, it's called segment any text, or SATE, worked really well, especially when they capped the maximum sentence length.
That makes sense.
Yeah.
You need those boundaries to be clear if you're trying to train a model to think in complete sentences. But I'm curious, how do they actually know if the LCM is working? How do they measure whether it's truly understanding these concepts?
That's a great question. They used a whole bunch of different metrics. Some of them focused on how accurate those concept embeddings were, and others looked at how well the LCM could predict what concept would come next in a sequence, or if it could generate text that actually made sense, was coherent.
So they're looking at both the quality of those individual concept representations and also the model's ability to kind of put those concepts together in a way that makes sense in a meaningful way.
Exactly. And one of the most interesting things they found was that the diffusion-based LCMs, those were consistently the ones that performed better than the more basic, simpler models. And this was across a whole bunch of different metrics.
So the diffusion approach seems to be winning here. But tell me, is the LCM just limited to text? Or can it work with other kinds of data too?
That's where things get really, really exciting. Remember that we talked about SONAR, that multilingual sentence embedding space?
Yes, the one that lets the LCM handle multiple languages.
Right. Well, SONAR isn't just limited to text. It can actually represent information from speech, images, even other modalities like music. And because the LCM is operating in the SONAR space, it has the potential to be this truly multimodal system.
Wait a minute. Are you saying that this model could potentially understand and generate not just text, but also images, music, maybe even video? That's insane.
It's still early days, of course, but the potential is definitely there. Imagine an AI that could just seamlessly blend information from all sorts of different sources. That would create this much richer and more nuanced understanding of the world.
That's mind-blowing.
Yeah.
It's like we're talking about an AI that could think more holistically, connecting ideas and concepts across like completely different mediums.
Exactly. And that's one of the things that makes the LCM so revolutionary. It's not just about like making language models more accurate. It's about rethinking, really rethinking the very foundations of AI and moving towards systems that can learn and reason more like how we do as humans.
Okay. So we talked about the basics of the LCM, the way it's structured, and its potential for understanding information from multiple sources. But now I kind of want to get into the nitty-gritty. I'm ready to go deeper into the training process and all the technical challenges that they had to face.
Let's do it. One of the coolest things about the LCM is how it can actually learn from data that isn't labeled, which is a huge plus in a world where labeled data is, it's hard to come by. It can be expensive to get.
That is fascinating. So
Yeah.
they're not actually telling the model what each concept means. It's figuring that out all on its own just by looking at huge amounts of text.
Precisely. They're using something called self-supervised learning. It's this technique where the model basically creates its own training labels by predicting parts of the text that are either masked or missing, like filling in the blanks.
Okay, so it's like this giant game of fill in the blanks, but at the level of concepts, not just individual words.
Exactly. And by just doing this over and over and over again, the LCM learns to represent concepts accurately. And to really understand how they all relate to each other in that larger context.
It's almost like the model is putting together a gigantic jigsaw puzzle.
Yeah.
But instead of using pictures, it's using concepts as the pieces.
That's a perfect analogy. And the more data it gets exposed to, the more complete and detailed that puzzle gets.
This is seriously blowing my mind. I'm starting to see how this whole approach could lead to some massive breakthroughs in AI, but I'm also thinking about the limitations. There have to be some challenges that come with working with concepts on this huge scale, right?
There are definitely challenges. One of the biggest ones is what the researchers call concept fragility.
Concept fragility. Okay, you've got my attention. Tell me more about that.
So it turns out that some types of sentences, like the ones that have a ton of numbers, web links, or code switching, those can be really tough for the LCM to process accurately.
So it's almost like those sentences are like potholes on the road to understanding. They kind of trip the model up and make it harder for it to really grasp the meaning.
Precisely. And the researchers, they really dug deep into the reasons behind this fragility, exploring those limits of the SONAR embedding space and, just the inherent challenges that come with trying to represent certain types of information conceptually.
So it's not just a simple matter of like tweaking the model. It's about really getting a handle on those fundamental limitations of the ways we're currently trying to represent knowledge.
Exactly. And the researchers, they suggest a few different strategies for dealing with this concept. Fragility, things like filtering out those problematic sentences during training or even developing more robust embedding spaces, ones that can handle those types of information better. They even tried specifically training the LCM on those tricky cases to see if it could learn to overcome those obstacles.
So it's like a multi-pronged attack, right? They're constantly trying to improve both the model itself and the data that it learns from. But I am curious about the bigger picture. What are the implications of the LCM beyond just like making language modeling better?
Well, one of the most exciting things about the LCM is its potential for what we call zero-shot generalization. That basically means that it can process and even generate text in languages it hasn't been specifically trained on.
Wait, you're telling me that it can understand languages it's never even seen before? How is that even possible?
That's because the LCM is working at a level of abstraction that goes beyond like any one language. It's learning to represent concepts in a way that's much more universal, more connected to the underlying meaning, not just the specific words being used.
So it's almost like the LCM is picking up on like the language of thought, a language that exists beyond any particular spoken or written language.
Yeah, that's a fantastic way to put it. That's what makes the LCM so exciting. It's not just a tool to make language models better. It's potentially like a key to unlocking this deeper understanding of how we think and how we communicate, and maybe even how we can build AI systems that truly bridge that gap between human and machine intelligence.
This is seriously mind-blowing stuff.
One thing that really jumped out at me in this paper was how the researchers really pushed the LCM to its limits. They wanted to see if it could handle more than just predicting the next sentence.
That makes sense. I mean, predicting the next sentence is neat and all, but it's not exactly like changing the world, right? What kind of challenges did they throw at it?
Well, they scaled the LCM up to a massive 7 billion parameters.
Okay, so they were giving it a supersized brain to work with.
Exactly. And then they tested it on summarization tasks, which, LLMs are already pretty decent at. But they also, they came up with this brand new task called summary expansion.
Summary expansion. I'm not sure I've heard of that before. What is that exactly?
It's basically like summarization in reverse. So you give the model a short summary, and it has to generate a longer, more detailed text, all based on that initial summary.
So it's like taking the seed of an idea and then watching the LCM like blossom it into this full-fledged story.
That's a great way to put it. It's a fantastic way to see if the model can actually generate creative and coherent text while still sticking to the information that was in that original summary.
It's a really smart way to evaluate how well it understands those concepts. So did the LCM do a good job with this new task?
It actually did surprisingly well, especially since it was, a totally new task that they just came up with. For the summarization part, they used those standard summarization data sets, things like CNN, Daily Mail, and XM. And then for the summary expansion part, they just took the summaries from those data sets.
So they were really pushing the LCM to its limits, testing it on like those well-established tasks and then this brand new thing. What did the results actually look like?
Okay, so for summarization, the LCM was right up there with some of the top LLMs. I mean, it even beat a few of them on certain metrics. And get this, it produced fewer repetitions than the LLMs, which means the summaries it made were more concise and readable.
So it wasn't just understanding the text, it was actually producing good summaries. That's pretty impressive. What about that summary expansion task?
For summary expansion, the LLMs, they tended to score higher on those traditional metrics, mostly because they were better at basically just recreating the original text almost word for word. But the LCM, it kind of stood out in a different way. It was much better at coming up with these new and unique sentences that actually expanded on the original ideas instead of just like repeating information.
That's so interesting. So the LLMs were kind of like parrots.
Yeah.
Just mimicking what they had seen before. But the LCM was more like a storyteller, weaving these new narratives from the threads of that original summary.
I love that analogy. It really highlights the difference in how the LCM approaches language compared to those traditional LLMs. It's not just spitting back information, it's actually understanding it and using it to create something new.
Okay, you've officially blown my mind. This LCM is seriously shaping up to be a game changer. But we've been focusing a lot on the technical stuff. What about its impact on the real world? Like, how could something like this actually change our lives? That's
where things get really exciting. Imagine a world where, AI assistants can not only understand what you're asking them to do, but they can also, reason about it, They can anticipate what you need and even come up with creative solutions that you might not have thought of.
So it's not just like asking your AI to set a reminder or play a song. It's like having a real thought partner, an AI that can help you brainstorm, solve problems, even explore new ideas.
Exactly. And it goes way beyond just personal assistance. Think about education. Imagine having AI-powered tutors that can adapt to each student's individual learning style, right? Giving them that personalized instruction and feedback. Or even AI systems that can analyze tons of educational data and find these patterns and insights that can help us make teaching better overall.
That would be incredible. No more one-size-fits-all teaching. Every student can have this learning experience that's tailored to their specific needs and their strengths.
Exactly. And then think about healthcare. Imagine AI systems that can go through medical records, genetic data, even lifestyle information, and then generate like personalized treatment plans. Or even AI-powered diagnostic tools that could catch diseases earlier and more accurately, so we could get better outcomes for patients and even save lives.
It's almost like having this whole team of expert physicians working with you, constantly analyzing data and customizing treatments to your unique situation.
That's a great way to think about it. And remember, this is all rooted in the LCM's ability to think in those concepts, to really get the meaning behind the information, not just the words themselves.
That's what makes it so powerful. It's not just processing language, it's like understanding the world through that language. But I'm sure even with all this potential, there's still some challenges.
No, of course. There are always challenges, especially when we're dealing with something as complex as AI. One of the biggest ones that they highlight is that we really need better concept embeddings. Remember, the LCM relies on that SONAR embedding space to represent concepts. But, SONAR has its limitations.
It's like trying to build a skyscraper on a foundation that's not quite strong enough to support it.
Perfect analogy. The researchers are actively working on finding these alternative embedding spaces that might be better suited for representing those more complex concepts. They're looking for ways to capture not just the meaning of a sentence, but also its relationships to other sentences, its place in a larger story, and even its emotional tone.
So it's not just about what the sentence says, it's about how it fits into that bigger picture and the feelings associated with it.
Exactly. Imagine an embedding space that could capture all the richness of human thought. The logic, the emotion, the creativity. That would truly be a game changer for AI.
It's almost like we're trying to create this map of the human mind. But it's not just showing those physical locations, it's showing all those connections and pathways that actually make up our thoughts and feelings.
I love that. And while the LCM isn't there yet, that level of sophistication, it is a big step in the right direction. It's showing us what could be possible when we start to think about AI in terms of concepts, not just words.
One of the things that really impressed me about this research was how open the authors were about the challenges that they faced. They didn't shy away from the limitations or even those potential risks of AI.
I completely agree. They're very aware of the ethical side of developing these increasingly sophisticated AI systems. And they stress how important it is that we develop safeguards, to make sure these technologies are used responsibly and that they benefit everyone.
That's good to hear. It's not just about building the most powerful AI, it's about building AI that we can trust and that aligns with our values.
Absolutely. And one of the key things they talk about is the need for transparency in AI development. We need to understand how these systems actually work and how they make decisions.
That makes perfect sense. If we're going to trust AI to make important decisions, we need to know how those decisions are being made. We can't just treat these systems as these, black boxes.
Exactly. And this transparency isn't just important for building trust, it's also really important for figuring out and addressing potential biases.
Right. If we don't understand how these systems work, we can't be sure that they're not perpetuating those existing biases or even creating new ones.
Precisely. And the researchers actually suggest several strategies for increasing transparency in AI development. Things like building more interpretable models and creating tools that allow us to visualize and really understand that decision-making process.
So it's not just about building smarter AI, it's about building AI that we can understand and that we can trust to make fair decisions.
Exactly. And that's one of the things that makes the LCM so promising. It's a step towards a more transparent and accountable way of developing AI.
We've spent a lot of time talking about the technical parts of the LCM and how it might impact different fields. But I want to zoom out for a second and think about the philosophical implications of this whole thing. What does it actually mean for a machine to think in concepts? Are we getting closer to creating AI that truly understands the world in the same way that we do?
Those are some big questions. And honestly, I don't think anyone has the answers yet, but the LCM is definitely making us rethink what we think we know about AI and what it can actually be.
It's like we're exploring this uncharted territory, venturing into this whole new realm of intelligence that we're just starting to grasp.
I love that. And even though the LCM isn't quite replicating the full complexity of human thought just yet, it's this fascinating glimpse into what might actually be possible.
It's also forcing us to really grapple with these deep philosophical questions about the nature of intelligence, consciousness, and, the whole relationship between humans and machines.
For sure. If machines can start to think in these concepts and actually understand the world at this deeper, more abstract level, what does that even mean for us? What does it say about how we see ourselves and our place in the universe?
It's both super exciting and, honestly, a little bit scary to think about all the possibilities. But one thing's for sure. This research is opening this whole new chapter in the story of AI, and I, for one, can't wait to see what happens next.
I'm right there with you. The LCM is a remarkable accomplishment, and it could totally change how we think about and interact with AI.
Okay, so we've talked a lot about the LCM. We've covered the technical details, the potential impact on different areas, and even those philosophical questions that it raises. But there's one more part of this research that I'm really excited about, and that's this concept of the long-form planning concept model, or LPCM.
Yes, the LPCM. This is an extension of the LCM, and it's designed to tackle this even more complex challenge, which is generating those longer, more structured pieces of text.
So if the LCM is about understanding and generating sentences, then the LPCM is about taking it up a notch, right? Thinking at the level of paragraphs, whole sections, maybe even entire documents.
Exactly. The regular LCM, it's really good at capturing what we call local coherence. That's that flow of ideas within a sentence or a few sentences. But the LPCM, it aims to achieve global coherence. So making sure that the entire piece of text is logically structured, well organized, and flows smoothly from start to finish.
That is a huge jump. It's like going from building a single-story house to putting up this massive skyscraper.
I like that. And the researchers actually pulled this off by adding in more information to the model. Stuff that goes beyond those sentence-level concepts.
Like what kind of information?
They included information about the structure of the whole document, like how paragraphs relate to each other, and even the overall purpose of the text.
So it's kind of like giving the LCM an outline,
Yeah.
like a blueprint to follow for putting that whole piece of writing together.
Exactly. The LPCM is designed to think more like a human author would, right?
Yeah.
Planning out the structure and the flow beforehand, and then making sure every part contributes to that overall message.
That's crazy. But does it actually work? Can the LPCM really produce long-form text that makes sense and that's comparable to something a human would write?
Well, they tested it out, and the results were pretty impressive. They found that the LPCM had much higher coherence scores compared to the original LCM, and that shows that it was able to generate text that was more logically put together and easier to follow.
So it's not just a theory. They actually built this model that can create coherent long-form text. That's taking AI writing to a whole new level.
You got it. And this is just the beginning. They think the LPCM could completely change how we use AI for a bunch of different tasks, from writing creative content to generating technical documents, even composing music or creating art.
It's like we're opening up this whole new world of possibilities for AI creativity. But like with any new technology, I'm sure there are still challenges.
Right, definitely. Yeah. One of the biggest challenges is figuring out how to scale up the LPCM to handle even larger and more complex documents.
Yeah, I can imagine. Going from a few paragraphs to like an entire novel, that's a massive jump in complexity.
Absolutely. It takes a ton of computational power and some really smart techniques to manage all that information and make sure it's all coherent at that scale. Another challenge is making sure that the LPCM doesn't just generate text that's grammatically correct and well structured, but that it's also engaging, creative, and emotionally impactful.
That's the ultimate goal, right? To create text that truly captures all those nuances of human language and that power of storytelling.
It is. And while we're not quite there yet, the LPCM is a pretty big step in that direction. It's showing us that AI can be more than just a tool to generate text. It can actually be like a partner in the creative process.
This is seriously groundbreaking work. I'm so excited to see where this research goes and how it shapes the future of AI and our relationship with language.
I couldn't agree more. The LCM and the LPCM are really amazing achievements. They show us the power of human ingenuity and what AI might be able to do to enhance our own abilities and help us explore those new frontiers of knowledge and creativity.
It feels like, we've only just begun to explore what the LCM and LPCM can really do. What are some of those like long-term possibilities that really get you excited about this research?
One thing that I find really fascinating is how it could potentially impact scientific discovery. Imagine the LCM or even the LPCM helping scientists analyze these like massive amounts of data, finding patterns and connections that we as humans would never be able to see.
So it's not just about writing like better stories or summaries. It's about actually speeding up scientific progress, maybe even leading to like major breakthroughs in medicine, energy, climate change, you name it.
Exactly. It could even help us understand the universe better. Analyzing data from telescopes and particle accelerators to unlock those secrets of cosmology and fundamental physics.
That's incredible. It's like we're talking about AI that can not only process information, but it can actually generate new knowledge, like
Wow.
pushing the boundaries of what we thought was even possible.
It's a really exciting possibility. And, the fact that the LCM can handle multiple languages, that could be a game changer for global collaboration. Imagine scientists from all over the world working together, sharing their findings and building on each other's work, no matter what language they speak.
That would be amazing. A world where knowledge is truly accessible to everyone, breaking down all those barriers of language and geography. But of course, like with any powerful technology, there are, potential risks too. What are some of the things that we need to be careful about as we move forward with this?
One concern is that it could be misused. As these models get more and more sophisticated, they could be used to create like really convincing disinformation or propaganda.
That's a good point. If it can write a news article that sounds real, or even a really persuasive opinion piece, then it could also be used to create fake news or spread harmful ideas.
Exactly. It's super important that we figure out ways to prevent that kind of misuse, and make sure that these technologies are used responsibly and ethically. Another thing to think about is how this might impact jobs. If AI can write reports, generate code, even create art, what happens to the people who are currently doing those jobs?
That's definitely something we need to consider. We need to think about how to get ready for the changes, those economic and social changes that AI is going to bring. Maybe it's not about replacing jobs, but more about like changing them, using AI as a tool to enhance our own capabilities and, free us up to do those more creative and fulfilling tasks.
I think that's a great way to look at it. AI can both create new opportunities and, potentially displace people from existing jobs. The key is to be proactive, right? To adapt to those changes, invest in education and training programs that give people the skills they need to thrive in this world where AI is becoming more prevalent.
It's about embracing the possibilities, but also being realistic about the challenges. But,
Yeah.
beyond the potential benefits and risks, there's something about the LCM that just sparks my curiosity. It makes me think about the very nature of intelligence. If a machine can think in concepts, does that mean it's really understanding the world in a way that's similar to how we do?
Oh, that's a question that philosophers have been debating for centuries. And I don't think the LCM gives us any easy answers, but it definitely makes us reconsider what we think we know about understanding.
Right. We usually think of understanding as something that's uniquely human. It's what sets us apart from other animals and definitely machines. But if AI can start to grasp those concepts, those relationships, and like reason about the world in a way that's more than just processing data, then maybe we need to broaden our definition of understanding.
Maybe understanding isn't this like all or nothing thing, maybe it's more of a spectrum, and maybe AI systems like the LCM are showing us that there are different ways to understand the world, different levels of complexity and sophistication.
It's like the LCM is revealing this whole new dimension of thought, a whole new way of looking at the world that we're just starting to explore. And who knows what other forms of intelligence are out there, both in the natural world and, in the world of AI.
It's an incredibly exciting time to be alive, to see these like incredible advancements in AI happening right before our eyes. I'm so curious to see what the future holds and how these technologies are going to continue to shape, how we see ourselves and the world around us.
I totally agree. Well, I think that brings us to the end of our deep dive into this world of the large concept model. It's been an amazing journey, exploring the technical side, the potential uses, and even those philosophical questions that it brings up. But as always, this is just the beginning of the conversation. We encourage you to keep exploring, to keep asking questions, to use your imagination, and, to join in the ongoing discussion about AI, the role it plays in our lives, and how it might shape the future of humanity.
Well said. Thank you so much for this really stimulating conversation and for bringing this fascinating research to our attention.
And to all our listeners, thank you so much for joining us on this intellectual adventure. Until next time, Keep those minds curious, keep those imaginations fired up, and stay tuned for more deep dives into the ever-evolving world of artificial intelligence.